Hello and welcome to a new video. My name is Herwig Juster and today we discuss the polymer material selection for electronic applications. Okay, let us get started. Today we have three different sections. So we start with the material selection criteria for electronic applications. Then we discuss some component characteristics and then we jump into selected materials. I have some commodity materials, some engineering polymers and some high performance polymers. Okay, the material selection criteria. So for electronic application, one of the most important criteria is wall thicknesses. So they are most of the time less than 1 millimeter. So the polymer must have good flow, melt flow during the molding process and without sacrificing any performance attributes. Then we have mechanical strength and service life. So you have to imagine when you have now thin wall thicknesses of less than 1 millimeter, so the product itself needs to have then also the necessary mechanical strength to fulfill the design purpose and also over the whole service life. So we talk here typically can be 5 years up to 20 years. Then also another important criteria is the dimensional stability. So we have to ensure that the selected materials has a shrinkage and warpage in a minimal range. So we have typical tolerances below 5 micrometers. And also this is particularly important for printed circuit boards, PCB materials, which need to be really flat to mount the different sensors on it. Then another aspect is flame resistance. So needs to be secured for UL 94 V0 level, also with the use of halogen-free flame retardants where possible. Then we have high thermal stability. So we already mentioned it, reflow soldering processes for the printed circuit boards. We have here temperature peaks 270 degrees C. So here the material needs to keep the shape and dimensions. Then chemical resistance. So all the selected materials need to be resistant to any chemicals which may splash or immerse with the component itself. So this can be hydraulic oils, cleaning agents and also all kinds of lubricants. Furthermore, it can also be that we have some sliding components involved in this electrical device. So if this is the case, this should be as less as possible dust production and to keep good tribological qualities. Then of course electrical performance of the material. So there, depending on the part and the application, the resistivity and tracking performance is needed. And also humidity is a point. So some polymers are subject to hydrolytic degradation and this can then in the long run lead to part failure. So this needs to be kept also in the back of our minds. Okay, now let's discuss some component characteristics. So when you look at the electrical components and in particular enclosures, there is the so-called ingress protection number, so the IP number. So it's used to express the protection against the ingress of foreign bodies or water. And depending also on the IP rating, several other things are affected. For example, the method of fixing used, the method of sealing, and also when you have then cable entrance into the device. And sometimes, so you have always 2 digits, but sometimes there's also a third digit added to express the impact protection. So let's have a look. For example, here is a table of the different IP levels. So in particular the first digit. And then here we have the second digit table. So when we take now example IP protection 66 means when we go here now in the table 1 on the 6th, that means we need total protection against contact and ingress of dust. And the second 6 is then here protection against high pressure water jets from any direction. So this is a typical IP scenario. So and this you have to consider then for the material selection, to always check such tables. Okay, let's continue with the selected materials. We start with the commodities, and here I've selected polypropylene because it's a well-known low-cost material. We have here a well-balanced relationship between toughness, stiffness and hardness, and also we have some heat resistance up to 100 degrees C. We have excellent resistance towards chemicals, low water absorption, and also low permeability to water vapor. It's easy and flexible in processing, so doesn't matter if you want to mold or extrude, and although we have a low density. And this results in the applications so that we have a variety of electrical and electronic applications. So here I named, for example, the battery containers, cable retention clips, screws, nuts and washers, for example. Okay, let's continue with the engineering polymers, starting with ABS. So here we have also good dimension stability at both high and low temperatures. ABS can be coated with metallic, for example, nickel. We have the UL94 classification ranging from HB to V0, and also excellent impact behavior. And a case use example is the intricate parts, for example. Then we continue with polyamides, PA. So it is selected for electrical and components because of the good chemical, electrical and mechanical properties of the material, combined with flexibility and relative immunity to fracture. So we have also a UL94 V0 with the use of flame retardants, and we can also withstand temperature up to 200 degrees C with the heat stabilization. Applications also a large field ranging from memory connectors, input-output connectors, board-to-wire, wire-to-wire connectors, so connectors in general, also modular jacks, micro switches. Then we have PPT. PPT is also used because of the high dimensional stability, good surface finish and good electrical and mechanical properties. And we have no dioxins or furan forming substances. Also a UL94 flammability classification from V2 to V0 is possible, and it is used in housings, connectors, micro connectors when you use high flow PPT, and also enclosures. Here again comes the IP rating into the game. And then I have also selected polycarbonate, PC, the amorphous engineering polymer. Here this is a rigid and dimensional stable material, has high impact resistance over a wide temperature range, also a good resistance to chemicals, and it has the advantage of transparency and good insulation properties. And when you look at the applications, here enclosures of the category 5 and 6 tend to be most of the time polycarbonate. Let's continue with the high performance polymers. To start with polysulfone, amorphous high performance polymer, which is tough, rigid and has high strength with a high heat deflection temperature. It has also a good dimensional stability with constant electrical and mechanical properties over the wide temperature range. Then we have an excellent surface quality of polysulfone, which enable that it can be metallized in a direct way. As applications, we have ranging from enclosures, sensors, bobbins, solenoids, connectors, and fuse boxes. Then we have polyphenylene sulfide, PPS. It's a semi-crystalline high-performance polymer, also especially known for its high heat performance, together with the high heat, high deflection temperatures, the range of 260 degrees C. We have exceptional processability with injection molding. That means we have an outstanding dimensional stability, in particular in injection molding when high precision molding is needed to fulfill severe tolerances. We have a high chemical resistance, and replacement of high performance thermosets or metals is possible. And for applications, PPS can be used for surface mounted connectors where we need these high heat deflection temperatures, and also replacing conventional materials in applications such as housings of mobile phones or other information devices. Then we have liquid crystal polymers, LCP. There we have the special molecular structure. So here you have to imagine you have rigid wood-like macro modules which align in the melt. So you have in liquid structures which have a self-reinforcing effect. You can imagine similar like glass fibers. It has extremely good flow properties, and this allows you to mold really thin walls of modern connectors. We have also continuous servo temperatures up to 240 degrees, short term even 340 degrees C, and there is no problem to use it in the soldering process. And this you can see also in the application, so it's used for connectors, thin wall connectors, printed circuit boards, everywhere where you have the reflow soldering process. Okay, if you want to find more information on polymer engineering topics, I highly recommend you my blog findoutaboutplastics.com, as well on material selection, my online courses. I will link you both the blog and the online courses in the description below. Okay, which video to watch next? This video on polymer material selection for automotive application might be of interest for you. Thank you for watching, and do not forget to subscribe and smash that like button. Till next time, bye.